Hi everyone, my name is Ethan Fedosi, and I'm a senior solution architect specializing in Microsoft platform with AWS. A quick intro before I start. I've been with AWS for about 18 months, and in my previous life, I'm working on the Microsoft technology stack for almost about, I would say, 20 years. My background is in application development, anything from .NET, microservices, containers, and most recently on a serverless architecture. In AWS, as I mentioned earlier on the call, we have a dedicated team under Windows to support all of the Windows customers that we have. For those of you who don't know, we usually get that question, that is it AWS is the best place to run Microsoft workloads on it, or is it Microsoft? So hopefully by the end of this conversation, which we're going to take about 30 minutes, you would have an idea about this. Let's see. Let me start with going through my slides. Excellent. So what I've prepared for today is that based on the stats that I just had, looks like that if 2/3 of our audience today is running Microsoft on AWS, perhaps what I'm going to discuss today about modernization would make sense a lot. But to make sure that we're all on the same page, I would just start with going through the Microsoft on AWS, the reasons, the why we think that is the best place to run Microsoft workloads, and also the migration strategies for Microsoft applications. And at the end, we discuss the few modernization paths for legacy Microsoft workloads. If you have a .NET application or SQL Server or any kind of workloads, how can you modernize and benefit from the clouds? So let me start with a few stats. I think that's very important to understand, because based on some IDC reports, we're seeing that currently it's about 70%. I mean, that report is based on 2018, but around 70% of the enterprise applications are Windows-based. That shows the popularity of Windows application. That makes sense, because I can think of a time that we all started to do some, if you have some coding background, we started doing, and the only options that we had at that time was running on the Windows, and Linux after that becoming more popular. But most of enterprise applications are running on Windows, and out of those 70%, 82% are still running on-prem, and that means that not many organizations have taken the approach to move to the cloud. There are various reasons behind it. It can be from the complexity of the legacy applications. We know that those thick client Windows applications, they are still out there. I've personally have experience to working on a few of them to modernize them. So there are challenges around moving to the cloud. But another stat shows that over half of those numbers are actually planning to migrate to the cloud within the next 2 years. And that shows the urgency and why we need to all think about moving from on-premise to cloud. But the question is that why we think that we should go to the AWS. This is another stat which I think that's very interesting, because it says that already 55% of the total Windows workloads in the public cloud currently run on AWS, and that's for 2018. And I believe that the numbers have been updated, but we don't have the updated numbers from IDC yet. That's almost double the size of the nearest cloud provider in 2017. And you know that who's the next cloud provider, but simply for those who might think that this is Windows workload, so the best place to run is on Azure, that basically proves that it's not a correct understanding of the cloud providers. The reason for that is that over the past 11 years, AWS has gone through a huge investment to supporting the Windows workloads. As you can see from here, the customer adoption over the years have been increased exponentially. And since 2008, that AWS has started to release the first services to support the Windows servers and SQL Server and .NET applications in 4 different categories, from the operating system to database and to applications. you can see the pace of innovation, how much new services and how many new features have been released. Just as an example, if you look at the, let's say just for the yellowish color here on the .NET, we can see that the .NET support started 2008, and then we released AWS tools for Windows PowerShell, and then moving forward, we have the serverless architecture to support .NET, and because of that, we started to support .NET Core, which is the base foundation to moving to the serverless. And after that, we have different monitoring, logging platforms, and CloudWatch app inside, and even more than that over the past year. So that means that there is a huge number of services are available. The support from the AWS for the .NET applications and for the Microsoft workloads have been increased. But the question here is that now, how can we actually leverage those services, and how can we start our cloud journey? So I like to going through different approaches that you can take. I call it here modernization, but basically you can refer it as migration as well. There is a definition for those terms that I want to show you later during the slides. But there are three main approaches. You might all have heard, I would say, a million times about the 6 R's of migration published by Gartner. And it says that there are different strategies that companies and organizations can take to move their applications from on-prem to the cloud. The top 3 of them, which is important for us, is rehost, replatform, and refactoring. So rehosting is running on the virtual machines or EC2 instances in AWS terms, and on the replatforming, you might go to the containers, and of course, on the refactoring, which to kind of building everything from scratch, you go to the serverless. Which option is the best for your workloads? It really depends on the workload, depends on the requirements, the OS dependencies. But what we need to keep in mind is that the level of effort would be increased as you move from the rehosting to refactoring. Now, let's take a closer look at each of them. When we're talking about rehosting, this is basically the lift and shift. That's where majority of organizations start, because depends on the IT strategy. They might think that they're not sure about what's the best approach to take. So they want to take a smaller step to just move from on-prem to the cloud, and by running the application on the virtual machines and EC2s. So there are benefits and there are disadvantages to that. Of course, it's the fastest way that you can take your workloads to cloud. There's not much architectural modifications required. Think about one website that you have today and it's running on IIS. So you basically go and configure your IIS application on the virtual machine, either manually or with the PowerShell script. You might copy your DLLs and files into the server, and with the minor tweaks, you might be able to start your application up and running. But basically, you will miss a majority of benefits of the cloud and the target platform. It can be both technical and of course, financially. There's not much cost saving into that. In contrast, we have replatforming. Replatforming is basically means that you're going to bundle your application in containers and run it into the either Windows containers or Linux containers. Of course, there are benefits into that in terms of scalability, how you can scale up your the number of instances that is running. Of course, supporting higher traffics for your websites or any portal that you have. A minimum modification is required for the architectures, but in some degree, there is still some work required. And in specific, when we are talking about legacy applications, it's not always as easy as just take it and create a container image and run it on the containers. Because I spoke about containers, I'd like to give just one slide, discuss the difference between the kind of legacy virtual machines and hypervisor that we all used to run versus the containerized applications. So as you may already know, on the left side, you can see that we had that infrastructure and operating system, and hypervisor used to be run on the infrastructure, and that hypervisor was responsible for managing the resources and memory and CPU allocations. And then on top of that, we had different virtual machines, which each of them have their own operating system, and the application was running. But we have the modern definition of the containers, and that's basically one operating system with some container management system, which all applications are running on top of it, which means there is more resources would be available to the applications. We don't need to run multiple operating system. And that Docker, which is an example of the container management service, this is basically helps to create and run, to manage and run your containers. And containers, again, just a summary, is a lightweight package that you bundle all of the software and dependencies that you have, the code, runtime, and libraries, and you just bundle it, and you can indefinitely deploy it into different containers. So on the third option, we have that refactoring. Refactoring is the least favorite option in many of cases. And the reason for that is it's not as easy as lift and shift. So thinking about a .NET application, if you have a .NET application or even a SQL Server database, if you want to fully benefit from the cloud, you need to go through kind of rebuilding the application or migrating to the fully new environment. If it's a website, let's say, you might change your architecture to serverless. Or if it's running on a Windows container, you want to switch to the Linux container, which you're going to save a lot on the licensing cost for your Windows operating system. The pro is obvious, is you get the full potential of a target cloud platform, but in contrast requires the largest investment and the level of effort. Now, this might give you an idea about the savings and the business value of efficiency. So this is an example that IDC conducted with 12 organizations running various Windows workload. When I'm saying Windows workload, it means anything from the Active Directory to SQL Server to the application level and file server and anything that runs on the Windows. And yes, and you can see they had about $5.6 million. The cost was the initial cost, which out of that, 1.8 million was around just for the power and facility costs, and the rest was just the hardware capex to buying the infrastructure. But over the course of 5 years, the saving was about 37% by moving to the Windows workload on AWS, and all they will be paying is just the AWS cost, and there is no more capex. So we all know that by moving to the cloud and migrating, we are actually trading the capex for opex, and all we are spending is for the services and on a pay-as-you-go pricing. Now, cost saving can be achieved at the beginning. So we all know that when cost is not always the key factor when it comes to decision to move to the cloud. However, the agility and innovations are usually the center of the motivation of organization when they decide to go to the cloud. But they still consider the cost. You can see on the left side that we usually and typically see at least 20% of saving just by going from on-prem to the cloud, and it's a typical lift and shift or rehosting that I mentioned. And then after a few months, by going through different iterations to optimize using the elasticity or right-size the instances. For instance, if this instance using too many CPUs that is not required, they can drop it. So that's what we call it right-sizing or the memory. And then constantly measure and monitor to improve the performance until we get to the point that we have this optimized EC2. That's where we still seeing that customer would save another 10 to 20% on their regular cost. And then after that, storage optimization, re-architecture to the serverless, or using managed services, using anything from EC2 to the managed services, until we finally get to the true AWS optimized instance and an architecture. That would be another 60% or more savings. So I think the key takeaway from here is that moving to the cloud and cost saving doesn't happen overnight. probably that's very obvious, but the way that you can increase it is by constantly monitoring your workloads and try to move away from the legacy workloads and infrastructure that you have and adopting into more cloud native approaches and services that exist today. I hope that gives you an idea about how, in general, organization can save money on by moving to the AWS and migrating to the cloud, and also how we can, one of the options that we can migrate our Windows workloads to AWS. Now, let's take a closer look at modernization and what it means. There are different this is a terminology that's been used a lot, but in AWS, what we're referring to is when we're talking about modernization, we're talking about a legacy application that you can imagine as a monolithic application running on Windows. It can be an exec file, it can be a website application, but in the backend is just one big DLL, a couple of DLLs that are dependent to each other. But through any of those approaches that I've mentioned, rehosting or replatforming or refactoring, you go to the microservices architecture, and that's where you will start to get the benefits of the new architecture, because then you get that opens up the new doors to the different platforms that you can use. You can run it on the Linux containers, or you can deploy to the several EC2 instances if you want to stay with the rehosting, and then scale up to using the containers. So this is what we call it as a modernization. But in a specific, when we're talking about modernization for the Windows workloads, we want to stay away from Windows operating system and moving to the Linux or open source platforms. And that slide should give you an example of that. So you can see that on the application and on the database side, if I can find my mouse, okay, here it is. So on the application side, you have .NET Framework application. That's a typical application workload on Windows. Majority of organizations are using .NET. Just FYI, I know that the .NET has been ranked as a number 4th popular programming languages amongst the developers. So we can expect that there is a huge .NET legacy application workload sitting out there on the on-premise, and they are moving to the cloud. And on the database, we have SQL Server, which is a standard database by the Microsoft, and we all use it a lot. It can be run either on premises or Azure or AWS. Now, going through the modernization pathway, there are different approaches that we can take. .NET Framework can be ported to .NET Core, and again, .NET Framework has been reached to the end of support 4.7, and Microsoft has been announced last year that they are not supporting .NET Framework anymore, except for some security updates. From now on would be .NET Core and .NET, which is the combined version of the .NET Core. They want to call it .NET 5 and moving forward. So by moving to the .NET Core, we can stay away from the Windows, and that's the interim step that we have to take. But we go into the Linux, and then once we are on the Linux, we can run the Linux containers, or moving to the Lambda. Both Linux containers and Lambda requires .NET Core, and .NET Core is basically can be run on a hybrid platform. It operating system, it supports Linux and Windows. So you can see that this is kind of very urgent for the existing .NET frameworks to move away from it. On the database side, we have SQL Server on Windows, but SQL Server can be run on Linux. That's one of the options that are available today by using RDS. And we have Amazon Aurora, which is the kind of serverless and open source database engine, and you kind of get a 5x throughput of a standard MySQL and kind of 3 times of the standard PostgreSQL server, and performance that it gets to the commercial databases is almost 1/10 of the cost. And I would cover it by the end of this this session today. So this is the option of for the modernization. When we look at that spectrum, in terms of what value you will get by going through each of those options and how much time and effort is required, that diagram might give you an idea. You see that on the left, if you just start by running application and deploy it to the EC2 instances, there is less value. But as you move to the right, by moving to the Elastic Beanstalk, for instance, or run it from the EC2 to the containers, porting to .NET Core, and finally moving your database from SQL to Aurora, there are many chances that you get more value. And on the most right, you see the cloud native approach. Cloud native is like serverless applications. That's kind of a trend these days. It's very hot topics, and everyone is thinking to just focus on moving away from a traditional three-tier applications, which of course is not a part of our topic today, but it's worth reading about it. Now that I spoke about serverless, I'd like to just give one quick intro about serverless, what it is. It takes several hours to discuss that in details, but basically to make sure that we are on the same page, serverless basically means that no server. And it's not about having no server at all. It means that customers and organizations don't see those servers, and everything is managed by AWS. So we all know that the less infrastructure that we provision, the more scaling decision is made on our behalf, and that's actually better. And with the serverless, we pay less for what we use, and we automate more. And by automating more, the less we care about availability. That's something that is managed by the cloud provider. So serverless supports the automatic scaling. We never pay for idle. If you have an application that just gets the traffic, let's say during the midnight, there is no point to put for the rest of the day. So we only pay for the time that the server or the functions our serverless application is getting getting invoked. There is no infrastructure provisioning. You just deploy your function and it would be available to run. And finally, it's highly available and fault tolerant. These can be an example of comparing two different options that exist today, and you can clearly say the benefits of moving to the serverless. The scenario is, let's say you have a website and that's receiving the 16,000 requests per day, and each request would take about 200 milliseconds, right? So that brings us to 3.2 million milliseconds a day. That's how much our infrastructure going to be used. Now, in the first instance, first scenario, actually, we have two EC2 instances. Even if we're paying for a 1 year upfront for the reserve instances and for both of them, and because we want to run it on the multi-AZ to be highly available using T3 large instance, that brings us $2.97 per day. That's the cost of running that application with that amount of traffic on the EC2. But in contrast, when we re-architecture to the Lambda and serverless with 1 gig memory size, and that can handle, everything is handled behind the scene for high availability and can handle the burst of the traffic, with that cost per 100 milliseconds, that brings the cost down to less than 5 cents a day. So no question, there's nothing else that I can add to that. The numbers clearly says the benefit of that. And the main reason is you only pay for the Lambda when it's invoked for the duration that is running. But for the EC2 instances, you are actually reserving those instances and they are sitting up there waiting for your request to come in. And even if you don't have any, you still have to pay for it. Cool. So another aspect to that serverless computing, when we're considering it to moving Microsoft workloads to AWS, basically we have two options. We can either re-architecture application to use the Lambda, as I mentioned, which is very common for the event-driven code execution. That, for example, is that when you're receiving your application, receive a new record in a database, and you want to propagate it to the different targets, or send an email, or notify someone else in the messaging queue. That's a very good example of using the Lambda. But if you're having a long-running application sitting there and running batch operations, for instance, or generating reports, you have an alternative, and that's Fargate. Fargate is a container management service, serverless container management service, and that provides you with the hassle-free container management, which is good for the long-running applications. There are a few differences, as you can see. With the serverless, you have that, so you your application can only run on the supported language runtimes. However, we can have the custom runtimes. But on the Fargate, you can bring your existing code, whatever it is, and it's a fully managed orchestration. But with the Lambda, you have a data source integration, which means that you can integrate different sources using the SQS or using the SNS and the different queuing and messaging platform which are available. So that brings us to the point that we discussed the different options for the applications. If we have a .NET applications, how, or any other kind of Windows applications, how we can modernize it with AWS. What are the services? What are the options and strategies? Now, the other side of all applications are databases. And we know that with Microsoft end of support for SQL Server 2008 and Windows Server 2008, there is a limit now that customers who are running these workloads, which is something around 64% of the workloads are running those SQL Server instances, it's very critical to find an alternative option to run the databases. So when we're talking about those three options of rehosting, replatforming, or refactoring, on the database side, it starts with the rehosting, which is kind of typical lift and shift, just to move away from your on-prem. There are two options. You can run SQL Server on Amazon EC2, which is similar to you installing SQL Server on one of your servers. You can do the same on an EC2. You have the OS level control and flexible licensing options. Whatever licensing you have, you can do the BYOL. But the other option is to go into Amazon RDS, which is the Amazon Relational Database System, and that's a managed physical infrastructure. And we know every time that you refer to a managed service, it means that AWS AWS take care of all of the infrastructure, and you basically don't need to worry about it. But OS installation, patching, scaling, everything's managed by AWS. All you need to do is that you make sure that your database just migrated using the existing tools, database migration system, and just bring your data and start connecting and tweaking your application to connect to that databases. There are some challenges with that. Of course, it doesn't support the Linux. It doesn't have the Linux support, but those are the two initial options that you can start with it, right? An alternative to that is modernizing the database, and what it means is that you move away from Windows as your operating system for SQL Server. And if you don't know, SQL Server can be run on Linux. This is a version of the SQL Server, and you can simply run it on Linux. There is no change that is required. It's a database. It's just a database migration, and of course, hugely we reduce the cost of the Windows licensing and support for it, and with some CPU optimized instances for the SQL Server, you're actually going to save a lot on the SQL Server cost. And of course, we have the Amazon Aurora. And Amazon Aurora, as I mentioned, is Amazon Aurora comes in the serverless architecture as well. It has, you can get the 5x day throughput of a standard MySQL. It support MySQL and PostgreSQL. And the cost for the commercial database is 1/10 of the cost of the existing one. One thing which is important here to know is that when, for whatever reason, we are modernizing, there is no question that we require some new skill set to be added to the team. Any organization that going through from Windows to the Linux, they need to have some Linux expertise in-house to make sure that they can support it. But the fact is that by moving to the Linux and moving away from Windows, we actually, that the experience of the DBAs in this specific scenario is going to change for better. We're going to improve our skill set in-house and make sure that they are capable of maintaining the infrastructure for us and for any upcoming changes that is required. So with that, I like to come to the last slide here and give you kind of a summary about what we had, and hopefully I would be able to send a message to you guys to understand that what it's going to take for you, what are the different approaches that you can take. And this chart and diagram might show you exactly the steps that you required to go from the Windows to the native cloud approach. So starting from on-prem, and then the time and effort that you need to put into that to go to the migration, first do the lift and shift, go to the cloud, and then start to think about re-architecture and modernizing, and finally getting to the cloud native approach. That's one path, but there might be some shortcut if you go directly from cloud native. Again, there is no blueprint for it. There is no specific formula that can be applied to any kind of all type of workloads. What is important here is that based on the need, based on the application and database and this IT strategy plan for organization, we've seen different approaches have been taken, either going directly to the cloud native or going through the migration, modernization, and then moving to the cloud native. So with that, I'd like to finish my presentation today. Please let me know if you have any question, paste in the chat window. I'm happy to answer a question. If not, let's get connected. I'm available on LinkedIn and Twitter. Or if you want to have any kind of conversation on the topics that we discussed today, please feel free to reach out to me to my Amazon email address. So thank you so much. And thanks, Ron, for giving me the opportunity.